Let's take the arrival of Alan
Yay.
as the sign that we should get this party started. He's muted, though, so we can't hear him. There we go.
Is that deliberate?
Big sigh.
All we get to hear is
It's a nice
big
entrance.
sigh. Not a ta-da. All right. Well, hi, everyone. Oh, I don't even have a... Who am I? Who is this guy? All right, there we go. Hi, everyone. My name is Fraser Cain. I'm the publisher of Universe Today, and this is your Weekly Space Hangout for October 25th, 2013. Today, we have stories about more information on the spacesuit leak, the asteroid panel that happened today. More information on other comets, not just ISID, but also ISIN. We've officially crossed the 1,000 exoplanets mark. Testing of the ExoMars rover, the furthest galaxy, Chinese scientists unbanned, cool activity on the sun, and hopefully we'll get to see a spider in low gravity. Joining me this week, an awesome panel of space journalists. First, we've got Alan Boyle.
Hi.
And we have no idea what Alan's going to talk about, so we'll find that out.
Neither do I.
No, you know what? You're going to talk about the asteroid panel because I know
Okay.
you were, you were
That's a
in
deal.
on that. Yeah. And then just like whatever, you just interrupt. At some point, interrupt whatever we're doing. Go, oh, I want to talk about this. And then
The usual in
yeah.
Thor.
Go ahead. Standard Alan Boyle technique. Amy Shira Teitel. Hey, Amy.
Hello.
We got David Dickinson. Hey, David.
Yay, it's finally fall here.
Is it?
Yes, it finally feels like fall here.
Oh, okay. Elizabeth Howell. Hey, Elizabeth.
Hello.
Oh, you've got the Vulcan salute as well. All right.
Why not? Yeah, Alan had that last week, and I
Yes.
decided to use the same thing. So.
My brethren, or sistren.
And Nancy Atkinson. Hey, Nancy.
Hi, we reach.
Okay, so I think the big story then today was this asteroid panel that happened. So it was sort of a live broadcast on how to protect the world from asteroids, and a bunch of people here watched it. We broadcast it live on Universe Today. So Alan, can you give people an update on what this was?
Sure. Actually, for years, a group of astronauts and experts on asteroids have been trying to figure out a process for dealing with the asteroid threat. What do you do if you do find an asteroid that poses a significant threat to Earth, and how can you do more to find those things in the first place? And so the UN has been involved in this process for years. Just this week, a committee of the General Assembly of the UN considered this plan that a lot of folks have been working for years on. And so this was the news peg for today's panel by 5 astronauts from various countries, U.S., Japan, and Romania, and moderated by Neil deGrasse Tyson. And so they laid out their action plan for going forward, very much based on the UN plan, trying to set up networks so that various space agencies can keep each other posted on what's going on with asteroids. And they also called for a couple of new missions. One would be an infrared space telescope that would be dedicated to looking for near-Earth asteroids from a vantage point that would be really useful, kind of inside the Earth's orbit, looking for these space rocks that may come out of the blue, like the Chelyabinsk meteor that we saw in February. And so they would like to see that launched by 2020, and then have something in the 2022-2023 timeframe that would be a demonstration of how you could push an asteroid around to get it out of the way. So that's the top line, really a consciousness-raising exercise for the asteroid issue.
And I mean, was there any ideas, anything in there that you hadn't heard before?
I think it's been knocked around a little bit, but the idea of trying to get a time frame and trying to lay out a timeline for these missions and to have an action plan, I think even though they've been talking about this for years, putting it all in order and trying to present it to the public, that's a really useful thing. I think, as Rusty Schweikert said, Apollo 9 astronaut who is part of this group, now we have the skeleton, and it's up to us to put the flesh and the muscle and the brains onto this skeleton.
That's a Sentinel. That's a Sentinel mission you're talking about, right, Alan?
Actually, that's something that came up, is that the Sentinel mission, which B612 Foundation has been working on, is one possibility for this. But there's another possibility called NeoCam that NASA has been working on, and so you've got these two missions. They're actually kind of complementary. NeoCam can do some more of the scientific work in addition to cataloging these asteroids. Sentinel is very much dedicated to finding and tracking these asteroids, and so I think when both these missions came up, Phil Plait said last year that we should do them both. But
interesting. I didn't know there was another one.
Yeah,
but it's great. I mean,
2016.
The B612 Foundation has really been tirelessly working in getting the word out, raising awareness, and staying on top of this even before the Chelyabinsk meteor and after. They've been doing a really good job. And I know Rusty Schweikert is part of that, and Ed Liu, and hopefully they're just going to keep grinding. And so if nothing from NASA or the international community ever happens, they're still pushing this agenda forward. Yeah,
that's why they're doing this, because they've been frustrated with how slowly things have been moving, and how difficult it is to get NASA really on board as much as they think NASA should be. And so they've been working to raise money. I don't know if there's an updated report. The last I heard was that they had $2 million or perhaps several $1 million toward what's expected to be something like a $450 million mission. So really all they need is one free-spending billionaire to get this going. But it's more difficult than you might think, and so I think they're trying to enlist not only NASA but other space agencies to support a Sentinel concept, or something that would do something very much like what Sentinel would do.
Yeah. And so do you think, I mean, was anything pushed forward beyond just kind of raising awareness and having this public conversation about it?
Just to try to get the space agencies working together. Maybe some of my esteemed colleagues here have some other thoughts they want to chime in with.
Well, one thing that, I've talked to Rusty Schweikert a couple of times, and he's very fond of saying that, this isn't the asteroid deflection scheme as far as protecting Earth when they find an asteroid that might be on the way to headed towards Earth. It's not something that's really expensive. It would take, he claims it would take only 1% of NASA's current budget to send a mission to do something like that. Now the big problem is that we can say that we can do that kind of thing, but we never tested it. And you'd hate to when you've got an asteroid coming at you and you need to do the mission right. It would be nice to have tested it out in some way.
And it's not going to happen, right? I mean, that they're going to leave it to the last minute, and then they're going to be it's going to be Bruce Willis and miners, and they're going to be with nuclear weapons, and it's not going to work, and people are going to die. And yeah, so you're absolutely right. I mean, they need to find them, and they need to understand them by putting tracking devices on these asteroids and seeing how they can monitor their position, and then they need to practice all the different methods that are proposed to see which ones actually will move an asteroid in a predictable way.
But Congress is the people that need to decide on this as far as NASA is concerned, and they're reactive, they're not proactive.
It's interesting that in hearings that have been held on this in the past, it seems as if members of Congress are really on board with this this asteroid threat. They're not crazy about sending astronauts to an asteroid and this whole asteroid mission that NASA has come up with. But when it comes to nailing down the asteroid threat and really doing something about it, it seems like there's a lot more support for that. So Fraser, maybe it's not as grim a situation as you think it is.
Well, it would. That if there was something on track to hit us, then people would scramble into action. But that's too late. But you know what we need? We need a Japanese cannon to shoot down the asteroid. That's what I'm thinking. And Elizabeth, what's the story here?
It's not shooting down the asteroid, it's shooting into the asteroid. There's a bit of a distinction there. It's not going to be moving it, it's going to be impacting it.
Oh, sure.
Yeah. Yeah, well, that's what they're telling us. I mean, that's what I'm going to believe
Sure,
until
why
I'm
wouldn't
told
they?
otherwise, I suppose. Yeah, exactly.
I want to
But
see like some big spaceship flying through space and shooting its cannons at various asteroids. But what are they actually planning?
okay, well, you talk to Alfonso Cuarón, and while you're doing that, I'm going to work on this.
Perfect.
So anyway, there's an asteroid out there floating in space called asteroid 1999 JU3, or maybe 1999 JU3. So anyway, several media reports came out this week just reminding us that the JAXA, which is the Japan Aerospace Exploration Agency, is planning to bring its Hayabusa 2 asteroid exploration mission to this asteroid. They apparently are on track to leave the Earth in 2018 with this spacecraft, head over to the asteroid, and then shoot at it. That's what we were talking about here. It's going to have a space cannon on board, which is basically a kind of a plain-spoken way of saying collision device, which is what they have. What they're hoping to do is to create an artificial crater on the asteroid's surface, and the idea would be that they can try and acquire a sample from that surface that has been recently exposed by a collision and hasn't been worn down over the ages by space environment or heat or any other sort of factors. And then they want to essentially pick up the sample and bring it back to Earth, just like they did with Hayabusa back in, I believe that was 2010 when they landed in Australia. So we'll see. We'll see if it gets up there.
Will it look more like a Star Blazers kind of cannon, like or a Robotech kind of cannon? I'm trying to understand what this is going to look like.
I don't know what it's going to look like, but maybe a Star Trek type of idea. I'm more of a Star Trek person myself,
Right.
so.
Right.
I know JAXA had some difficulties. They had some difficulties with the gun on the first Hayabusa that was supposed to stir up the rock samples when it came and just kind of touched down on the asteroid Itokawa very briefly. So,
I mean, we've had the impactors with the lunar impactors and the asteroid impactors that have happened already, deep impact, things like that. So, I mean, is it sort of the same idea, but shooting it from a little bit farther away?
Well, I'm sure the thing is that JAXA is looking at whatever happened with the Hayabusa, because there are a few technical problems with that. But, given, that situation, it was a pretty bold idea at the time. They're going to be bringing a spacecraft out there and picking up an asteroid sample and then bringing it back to Earth. That was quite a complicated feat. Yeah. And the fact that they were able to do anything at all at that point was probably pretty momentous. But, being space engineers, anybody would want to do better the next time. So maybe it'll be glitch-free if they're lucky.
That'd be great.
Yeah.
Cool.
We'll talk about some other objects in space. Now, we've been like ISON Watch 2013, and we've got some more images of ISON that have been coming out, and I'll try and dig some up. But David, you're pleased to note that ISON's not the only comet that we're looking at now.
We currently have 5 comets that are above 10th magnitude right now, and I was looking at one this morning. It's currently the brightest comet, and I wrote an article about it Monday on Universe Today. Comet 2P Encke is on a 3.3-year orbit. It's got the smallest periodic orbit of any comet. And we've got a pretty good favorable apparition of it right now. And it's also in Leo, in the constellation Leo, just like ISON. It's not that far away. And as a matter of fact, they're going to be following the same track through the constellations Leo into Virgo as ISON makes its plunge down to the sun. They're along our line of sight. They're not actually close to each other at all, but there are going to be some photos probably mid next month. Somebody will be able to grab some photos of both comets at once. I was looking at Encke this morning. It's about 8th magnitude. ISON I did not see, but the moon is still waning gibbous in the sky right now in the morning sky. So we need about one more week for the moon to move out of the sky again so we can start seeing these comets. But it's kind of cool that ISON's still up there near Mars in the constellation Leo right now. Yeah, there's ISON right there.
Yeah.
And no sooner than I finished that article on Comet Encke Monday night than I started getting some chatter from some of the comet tracking message boards that a certain really obscure comet that nobody was tracking suddenly brightened about 100 times. So I was scrambling to try to get some kind of confirmation on it, and it did indeed. It was Comet 2012 X1 Linear, one of the linear comets that's discovered by the Linear Survey in Socorro, New Mexico. This is an automated survey that's looking for near-Earth objects, but this comet brightened up to binocular range about 8th magnitude. It is in the constellation Canis Venusati right now. Probably slaughtering the name on that, but it's very tough to see. I did not see it this morning. I'm going to keep looking for it with binoculars, and I've got an 8-inch Schmidt-Cassegrain telescope I'm up with. We have some very good clear skies in the morning right now. Well, that's a cool animation of ISON right there.
Isn't this great?
Yeah. But the brightening of X1 Linear is reminiscent of Comet Holmes back in 2007, late 2007. which that brightened up to naked eye. That was really cool because you could go out that night and actually just look up in Perseus and see it. That was kind of cool. I don't know if X1 Linear is peaked out right now. It may brighten some more. Again, I haven't seen it. It's really low to the horizon in the morning. At sunrise, it's about 15 degrees above the horizon from 30 north here. The further north you get, you might gain a little bit of elevation on it. I've seen some amateurs have managed to photograph it right now. Yep, there's Mars, and yeah, it's been cool that people have actually been getting Regulus and Mars and Ison paired together. And I think in about a month you're going to see Ison paired off with Comet Encke too. That will be cool because we don't very often get two comets in the same frame, so that's going to be kind of nifty. And I'm interested to see if they're going to get, if anybody's going to get a glimpse of Ison during the hybrid solar eclipse. Me and Michael Zeller have been talking about the prospects on that. It's probably not the first thing I would be looking for during 45 seconds of eclipse, but somebody might get a look at it.
That's really cool. That's great. It's great there's so many comets.
Yeah. Hopefully they get brighter right now. They need to get. I've noticed that really, I usually think binocular range for something is between higher than 10th magnitude, but when it comes to comets, it's more like 8th magnitude because the same thing is like when you're looking at globular clusters or nebula, you've got that brightness, but it's spread over surface area. So a 10th magnitude comet tends not to be visible in binoculars, at least when I've looked at it. They usually got to hit about 8th magnitude or so.
Very cool. Well, now I want to talk about... I haven't talked to Amy yet. Amy, let's talk about the furthest galaxy again.
Okay. Sorry, did you do this one last week? Did I miss it?
No, we didn't. It's just that it's always the furthest galaxy, right?
Well, yeah. If you find something further, then you get the furthest galaxy sash until the next person comes on. Okay, so before I start, I'm just going to give the name of this galaxy once because it doesn't have a proper name yet. It is currently called Z8_GND_5296. So for anybody who's interested, that's the galaxy's name. I will heretofore refer to it as the galaxy.
Let's just call it Zed.
Zed, all right.
It's got a phone number for identification.
Yeah. Okay, so it's the furthest galaxy. Yes. The discovery came from a team of astronomers at the University of Texas, Austin, led by an astronomer named Stephen Nicole, who's worked, among other things, on the Candles survey that NASA's Hubble Space Telescope did. So this was looking at all kinds of distant galaxies. And what his team did was pick 43 candidates that they thought might be super far away and worth observing from ground-based observatories to actually sort of nail down what exactly it is. So using the Keck telescope it's the one in Hawaii, right? Using the Keck telescope, they figured out that this one galaxy that they found, Galaxy Z, is actually 700 million, dates back to 700 million years after the Big Bang. So that's kind of a weird, I find this time thing really hard to get your head around, but that's super old but also really young on galactic scale when you think about the universe being 13.8 billion years old. So how they did this was they measured the redshift of the galaxy, right? So because the universe is expanding, you see the shift of light, or the light is shifted towards the red end of the spectrum, and they measured the shift at being 7.51, which equates, through some, astronomer's madness, maybe David can fill us in on the details, to the galaxy being 700 million years old, or years young, rather. So what they're trying to do with this, and why this is interesting, is that astronomers are trying to figure out how galaxies evolve and change, and sort of give us an understanding of why, or rather how the Milky Way came to be how it is, and how maybe we're here, by looking at galaxies that are different ages to see how they've changed at different points in sort of general galactic history, which feels like a really big thing to be doing, but also really cool. So this is really neat that now there's a new reigning champion of oldest galaxy to kind of give that benchmark of what a fairly young galaxy looks like.
Right, because I mean, you've got this situation that a few hundred million years after the Big Bang, you're starting to get these big stars, you're starting to get these first tiny galaxies, and the question is, how did these things come together to form the big, massive spiral galaxies that we have today? And so the problem is that these old far galaxies are also small and dim before the big spiral ones started to form. So that's still, that's still a big mystery. They're still trying to figure out that early galaxy evolution, and that's one of the jobs of the James Webb Space Telescope, is it's going to be able to to look right back to the very edge of the observable universe. And,
Which is going to be
and
so
pick that up.
cool.
You know what's crazy, and I've just been working on a video about this, so it's sort of fresh in my head, which is that that galaxy is not 13. You'd think it would be 13.1 billion light years away from us, right? Because but it's not, because the universe has expanded.
Right.
Like 90 billion light years in that time, 93 billion light years. So it's actually more like about, I don't know, 90 something billion light years away from us.
That is the toughest thing to explain to people. I had somebody ask me that at a star party, and I was like, in a short answer is very tough to explain in the dark.
yeah. Like, what is it? Sorry, the radius of the universe is like 47 billion light years across, and so
you would think it would be its age times 2 would be but actually the universe, there's nothing that says expansion can't happen faster than the speed of light. Yeah. So but it's very
far.
Yeah.
It's also tricky anytime you say anything is farthest or fastest or whatever, because there's always some sort of asterisk. In this case,
right. I should say farthest known.
Right, or farthest verified, because Hubble has identified some that appear to be farther, but this is the farthest that's been verified using other means to get its spectroscopic signature. So
and as soon as the James Webb does launch, all these records will just fall to the wayside, and this will be nothing. It's like when they had there's new technique.
Look forward to that.
Yeah, well they had that with the Discovery. We were talking to Mike Brown a few years back, and they, once they had a new set of instruments, they were able to pull out a lot of the bright Kuiper belt objects and build up that series, Makemake and Eris and so on, Haumea, but that's kind of it. Now they're going to wait for a bigger instrument to sort of do another round of finding big objects. So
more planets,
more PhDs.
Yes.
Yeah. Speaking of more planets, now David, last week you said that we were almost 1,000 exoplanets. Are we 1,000 exoplanets?
Yes. As per the Exoplanet Encyclopedia Online, we are now at 1,010. They kind of update sporadically, so I kind of knew last weekend we had to be at 1,000 because they were at 999, and then there was that one Pan-STARRS rogue planet we reported last week. I looked through the database. That one wasn't in there, so I think we were actually at 1,000 a few days prior to that. But we live in an age where there's over 1,000 exoplanets now. Most of them have been found by radial velocity and transit measurements. It was interesting because I was talking about this on a panel at Necronomicon last weekend too, so it was kind of timely. That just kind of all fell together that way.
How many people can people name? I'll go first. 51 Pegasi.
52 Pegasi.
Oh.
No, there's like there's. I remember back before '92 when they found the first exoplanet orbiting a pulsar, when they were talking about whether they would ever be able to find like exoplanets, around stars. So it's amazing we live like 20 years later, a whole generation has grown up knowing nothing but exoplanet science. So
what I find funny is how sometimes I'm writing about the same systems over and over again, like LEAS 581. I think I've written about 10 stories about them in the past year because new things keep getting discovered with that. So.
That's the one that's almost Earth-like, kind of, maybe. I think.
Exactly, yeah, but they keep changing their mind, right? So.
Yeah. There's technically none that fit the Goldilocks zone in the right mass. There still isn't an Earth analog out there, and I'm always kind of skeptical about claims of it because you think about Venus in our own solar system. It's an Earth twin in a lot of ways, but I wouldn't build an interstellar arc and head off to Venus just yet. So if they found it 10 light years away or something like that. So I think we're going to find even Earth-like planets can be drastically different.
Alan Boyle, I know what I want to hear from you. I know what I want you to explain to me, which is that I can take a trip to space on a balloon for $75,000.
Oh wow, the Worldview balloon, yeah. That seems like so long ago that they announced that, but that's pretty cool. We've talked about suborbital spaceflight as kind of the next frontier for space tourism. You can reserve your seat on Virgin Galactic for $250,000. You can reserve a seat on an X-Core rocket plane for $95,000. So here's a new twist where the Worldview will take you up in a high-altitude balloon to an altitude of something like 19 miles or 30 kilometers. And it's not just for a few minutes like it is with a rocket plane. You can stay up there for a couple hours and just look around, have a picnic up there. God knows what you could do if you sold out the entire gondola. It's a balloon gondola aimed at seating or having 6 passengers and 2 pilots. Eventually they'll go to 7 passengers and 1 pilot. So it's an interesting option. I've always thought whenever you see these high altitude balloons sending up action figures or God knows what to the edge of space, you could do that with people if you could assure the safety, and so that's what these folks at Worldview are doing. The leaders of the project are Jane Poynter and Tabor McCallum. A lot of space fans know those folks because they're the founders of Paragon Space Development. They're involved in Inspiration Mars. They were actually in the Biosphere 2 so long ago. So this is a very substantial group. They're getting money from venture capital firms that specialize in resort development. So it's a going concern. They expect that they'll be able to start flying somewhere around the end of 2016, and the price tag, $75,000. It's still a little bit out of my budget range right now, but if you can't afford the $250,000 or the $95,000, here's another option for you.
They're going to need somebody to provide a critical review, someone to report on the story. So I think
There you go.
you've done the vomit comet, haven't you?
I did a zero-G flight, yeah. So
Yeah.
if you're looking for zero-G, this is not going to give it to you. It's going to be your typical balloon ride in terms of the effects of gravity, but the view is going to be spectacular.
Well, it will be, but I'm, when you think about the mission profile, those weather balloons that they launch these action figures up into space or to that high altitude, the balloon gets so big and then it pops. Right? That's the way the mission ends, is when the such low air pressure that the balloon just grows and grows and grows and then pops.
And then you find your Captain Kirk action figure sitting in a briar patch somewhere in Nevada. But,
so how are they planning to deal with the fact that their balloon will likely pop?
Parasail, my friend. They have a parasail attached to the balloon, and so those details I'm a little bit fuzzy about, but the idea is that eventually the parasail is going to bring it back down to somewhere near the launch site. But you're right that there are a lot of concerns about, for example, wind. You want to make sure that the conditions are right. These folks don't expect to launch a balloon more than once a week, and so they have to be careful about the conditions for doing this sort of flight, and I think that's one of the aspects that they're going to have to cover. The FAA is going to consider this as a spaceship rather than a balloon gondola because you are facing conditions that are very space-like, even though you're really not anywhere near the 100-kilometer mark, which is generally considered the boundary of outer space. And so that was one of the reasons why they're talking about this now, is because the FAA recently sent them a letter saying that it would be considered governed by the rules for spaceflight launches, even though there are no rockets involved.
But this is very similar to what the Felix Baumgartner launch was, right? Imagine
Indeed,
that.
Yeah.
Except you don't jump off.
Don't jump.
Don't jump. Whatever you do, just stay in the balloon.
Mm-hmm.
Yeah. No, it sounds like madness. That's what it sounds like to me.
You're gonna pay if you pay my way, I'll go, Fraser.
Will you?
Well,
Yeah.
you should use your influence to get all of us up there to do a hangout.
There you go.
It'll be
Hang out
There you
the first.
go.
There you go.
great. Critical reviews.
Hang out from the
tolerant
edge of
jokes.
ultimate
space.
From the edge
Yeah.
of space.
The ultimate hangout.
I will
There you
see
go.
you guys.
That's a
I will
great
do
idea,
this
Amy.
from ground. No, I would do it if I could. I would. Okay, well, Nancy, I want to talk about our crazy sun.
Yeah, if you're up there in that blue, and you might want to check the sun forecast. Our sun is finally acting like it's in solar maximum. We've got, let me see here, 1, 2, 3, 4, 5 sunspot groups on the sun right now. And today we've had 2 X-class flares from the sun. So that's kind of exciting, actually, because it's been so quiet from the sun lately, even though it is in solar maximum. So, so we've had 2 X-class flares, and then yesterday there was another one. a lesser class. So anyway, we don't have to worry about that here on Earth, but it could affect our communication satellites. But and the other thing is that we could get some aurora. So I haven't heard. Has anybody else heard how how these are pointed? Are they directed at Earth? Close.
These sunspots right here, they were pointed at. They're rotating away right now. They were pointed at Earth a few days ago, but we've got more coming around the limb too.
Enjoy this video, people.
That's the most terrifying thing.
I know.
Yeah,
this
Awesome.
This was from the end of September, and it was that people had not really seen on the sun before. It almost looked, as Jason Major, that the sun split apart. This huge filament just shot off the sun and created all these different. You could see all these different layers in the sun's corona, which we really haven't seen before. So it was just this huge storm. It was plasma, magnetic fields, and just pretty amazing. It's I could sit and watch that video all day.
all day, yeah. But it's also kind of terrifying that this is what we have nearby.
Yeah.
I almost kind of wonder if we might have a repeat of the 2003 Halloween solar flares we had back last solar cycle, because we are coming up on Halloween next weekend, so next Thursday.
How spooky.
You guys are missing the cool music that NASA put with this. It's great. You got to listen to it.
And just one
What
other
I've got
point.
up right. Oh, go ahead.
One other point was that I've been getting some emails from people wondering if Comet Izon is causing all this on the sun right now. The quick and easy answer is no.
No.
Yeah.
The longer answer is don't be ridiculous.
Yeah.
The image I have right now is I took from the backyard here. I shoot the sun every day. I'm doing a solar animation movie of the entire solar cycle, and that's what the sun looked like about 2 hours ago, in white light, filtered.
Nice.
David, how long have you been doing that video? You said the entire solar cycle, 11 years?
I've been doing it for a couple of years now, since I've had my DSLR in 2009. So I'm hoping to make a little animated GIF of the entire, and some other effects that you can see, like the solar rotation. I've done some slower ones of the solar rotation, things like that.
But you're going to try and do like an animated GIF of the entire solar cycle?
That's kind of the thought. Yeah, I don't know how it's going to work out, but it's worked out pretty well with the rotation movies. Just animating, because that's only like 22 days to do the entire GIF of you can see the sun rotating. But a lot of people have done those. This is a little more ambitious, so we'll see how that goes together.
It really is. Can we get an exclusive on that when you're ready?
Yeah, give me about 9 more years.
Okay. All right, 9 years. So we've been going for almost 15 years now, so no problem. Oh, Elizabeth, you've turned into robot Elizabeth. No, can't hear a word you're saying. So I'm sure she's dropping now. We've talked about that. We've talked about that. Oh, and all the stories I have left are for Elizabeth. Okay, so we're going to talk about some Chinese scientists that have been unbanned.
Unbanned. Yes. So the backstory here is that there is a Kepler mission conference next month at NASA Ames, which is in California, and NASA had previously issued a ban saying that any Chinese scientists were not allowed to come. This goes back to a law. Oh, I don't know all the, and let's just call it a counter-espionage legislation or law, because I don't know all the details of this whole thing, but basically it prevents any people that work with the Chinese government or any Chinese-owned companies from interacting with American scientists, and it bans NASA from hosting any Chinese people on their sites, so any NASA land. So this is quite problematic, because you can imagine, I mean, it's like in the States. Most scientists are affiliated with a government agency or a government-run or funded institution, like a university. Same thing in China. And also there are students, Chinese students studying here that then can't go to NASA somehow. This has been a little bit strange, and NASA has repealed the ban, which is a good thing. Because really, it's exoplanets. Or do you think there are going to be people muttering about national security and national secrets in the hallways? They're just going to be talking about aliens and alien life and cool alien worlds. So NASA lifted the ban, citing a misinterpretation of the initial legislation. this sort of, I guess, loophole, as it were, is that NASA can host and discuss work with individuals as long as they aren't acting on behalf of a government agency or a Chinese-owned corporation or company. So yeah, that's a good thing, because it's, I guess, the starry-eyed optimist in me, which is a small part, but you know, space exploration and space science and these things should really not be politicized. I mean, think about how much more we could do if we had the resources of all of the brilliant people in the world, just, you know, not just the brilliant people from one part of the world and the brilliant people from another part of the world, duplicating things like space stations and ways to get into Earth orbit. We could have so much amazing stuff if we pooled all the resources. So it's kind of, I kind of see this as a step. I don't know. I mean, it's really hard to say anything about American relations with China because there's so much going on there. But at least with science, there's a little bit of détente, maybe, briefly.
The treaty you're talking about is ITAR's, International Traffic in Arms Regulations. It's left over from the Cold War, saying that there's certain technologies that we don't want to share. A lot of it has to do with computer and nuclear technology, but yeah. Right.
But this law that formally that NASA is citing as being the reason for the ban was only passed in March.
Ah, okay.
So I'm not entirely sure where it's coming from, how long it's kind of been in the pipeline.
It's interesting.
To that. I mean, it's obviously a Cold War holdover because of the, you know, ties with the Soviet Union and still being, you know, the fundamental ideological differences between the two countries. But yeah, it's a little bit unclear where this is coming from, but it definitely has roots that will not be solved because we all love exoplanets. But at least they can talk about exoplanets.
It kind of comes from funding legislation that Congress has said that NASA can't really use funds for bilateral contacts with the Chinese, and so it's buried in the funding legislation.
Right.
Yeah.
But that doesn't say anything about multilateral summits, right? Which is why it's odd that they wouldn't allow Chinese research, you know, students that live here now, or, you know, there's other nations present, so why that would somehow preclude Chinese participants, which is odd. But,
right.
So just got a couple of comments here I wanted to bring into this. One is X-Man049 says that Sirius Radio just launched a satellite about 30 minutes ago.
Yes. Yeah, I was watching that live out of Baikonur. They just launched. That's the first launch broadcast of October. We had 2 launches today, as a matter of fact. We had no launches in October up until today.
Shadowlang404, what's the link for the Sun video? It's on Universe Today. We'll have the links posted after. Normally Nicole does all this stuff live, and it's just one more thing that I can't do. Yes, Elizabeth, we could see you.
Okay, I was waylaid by a solar flare. I just wasn't sure. So.
Yeah. It's like some science fiction. Can anyone see me? It's like some Star Trek episode. You're in some other dimension now. Where's Elizabeth? Why hasn't she returned yet?
Because I was in an alternate dimension, obviously. So.
Do you guys hear some kind of ghostly sound? All right. So before we get to Elizabeth, I want to sort of spring another story on Alan. And I want to talk about lakes on Titan. Alan,
Lakes on Titan. Yeah, actually, we've known for a while that Titan has hydrocarbon lakes with methane and ethane, and there's a whole hydrologic cycle that goes on where you've got methane rain that's pools into these lakes, and it's pretty cool. Cold, actually. The reason why this happens is because it's so cold on Titan. But there's a part of that hydrologic cycle where the stuff evaporates, and what the most recent pictures from Titan flybys show is the stuff that's left over after the methane evaporates. And so that was the cool part about that particular picture, is that you can see organic stuff that is sitting in what would be the equivalent of salt flats. They're not technically salt flats because these are not technically salts. They don't know exactly what the organics are, but you know, it's probably some hydrocarbon schmutz that is left behind by the evaporation of these pools and lakes. And so it fills in another gap in our understanding of how Titan's weather works. And eventually we might be able to kind of trace how this all works together, whether there is some sort of reaction with this schmutz, that's the technical term, and you know, it's just more knowledge about how this weird moon of Saturn works. It's the only moon that has a dense atmosphere, but Cassini's infrared instruments are able to look through the murk and see what's going on at the surface. It's one of the most fascinating places in the solar system when you get beyond our own little home planet.
Yeah, you wouldn't need a pressure suit to stand on the surface of Titan because the air pressure is what 1.5 I think, or twice the density of Earth. So you would just need a really warm coat and some way to breathe.
Right. If it would be problem solved for the energy crisis if we could get all that methane back.
Yeah.
Think about it.
Think of the global warming. So one question comes from Andrew Planet. Could you launch a rocket from a high-altitude balloon-supported platform and save cost in the process? I've heard this idea kicked around a couple of times, right?
Yeah, as a matter of fact, one of the X Prize contestants was from Canada. Brian Feeney was going to do that. They had a what did they call it? A raccoon that was going to go up from Saskatchewan or someplace and drop a rocket and blast off from there. But it's very technically challenging to do that. Really tough when you've got a balloon with a rocket attached that you're going to drop and try to keep everything from blowing apart.
But I wonder if you could even just take your rocket, you need a really big balloon platform and just try and counter some of that initial launch mass. So just that because that first part where it tries to get off the ground, and then if it's got some upward velocity, and then let its engines ignite. But it's just adding a lot of shenanigans to the launch.
That's how Van Allen did some of his experiments.
Launched from
you can do sounding rockets.
Did the I can't remember the details of it, but it has been done, and it's been done with success at some point. But
sounds like a historian should dig that up.
Tiny, but his instruments were tiny little things. I don't know what kind of payload you could seriously launch from a balloon like that.
I will have to simulate it in the Kerbal Space Program. I will get back to you. Okay, so now let's talk about, we've talked about that, we've talked about this. Let's talk about an update on the spacesuit leak with Elizabeth.
Well, as probably everybody remembers, back in July, Luca Parmitano, the Italian astronaut, was outside doing some work, and then he had this sudden water leak happening in his helmet. And so, obviously, a pretty serious situation. He and his crewmate Chris Krasny made a quick exit from the spacewalk and an entry back into the space station, and all was well, in the short term. But NASA does not want that kind of thing to happen again. So they're actually running two parallel investigations. One is supposed to be looking at procedures, and the other one is supposed to be looking at the spacesuit itself. And so the spacesuit's still sitting on the station. Cassidy himself had a look at it, and back in July was tracing where the leak happened and all of that. And they're still not sure what's going on. So essentially, what happened this week was Mike Hopkins and Karen Nyberg, who are both on the station right now, started to take the thing apart. And they were trying to replace a fan pump and water separator inside of the spacesuit. And this is essentially how it works. I'm getting this right from the NASA YouTube video. So there's a motor inside the suit. It drives the fan pump and the water separator. The fan circulates the oxygen, and the pump pumps the coolant fluid. The water separator then takes out the moisture or the water from the ventilation loop and the gas that could be trapped inside the water coolant loop. And then this dried out air is then returned to the crew member for breathing, and then it sort of goes on from there. So they think that there might be a problem with the water separator. They don't know exactly what it is, but they're hoping that by removing the unit, putting in a new one, and kind of playing around with the suit a bit more and taking a look at it, they might be able to come up with some answers. But if that doesn't work, there's another option as well. They're planning, from what I've heard from Chris Cassidy a couple of weeks ago, they are planning to actually bring the spacesuit back to Earth for more detailed analysis. It just has to wait until the next SpaceX Dragon flight gets up there. So hopefully they'll get this thing fixed soon, because they can't do any spacewalks until this all is done. On the NASA side anyway. The Russian side is okay because they have the Orlan spacesuit.
Very cool. And scary, but but it's sort of keeping them busy up in space.
Well,
figuring
yeah,
this
and
out.
the important thing is they're working on it. You know, they're not sitting idle, and they're going to be NASA and go and try and find a fix for this. So hopefully that happens sooner rather than later.
All right, I am going to show you a really cool video now. Hold on a second here. Come on, little... Oh, it's not going to go full screen? What? Internal monologue. Okay.
I'll show you something cool real quick.
Let me see if this works. I don't know why I don't want to go bigger than this. Okay, Nancy, what are we looking at?
We're looking at a spider that flew to space back in 2012, and it was the first spider that actually survived both liftoff and return. So it actually survived after it came back home, and so they were able to kind of monitor it after it got back home. And it's just even though this happened last year, the video of it just came out this week, and it's kind of interesting to see the spider just kind of is going to attack some of its prey, and basically it does a backflop. It's kind of lost its coordination, and it's kind of interesting because we hear from the astronauts when they come back long duration stays in space that they're wobbly on their legs. They some of them have actually fainted or fallen over, and some of them they'll put something down. They think they're putting it down, but they just put it up in the air from what they're used to doing up on the space station. And of course it drops. I think Mike Massimino said he broke some eggs when he was putting them away because he just thought he could stick them right in the air.
Just leave eggs in the air.
Yeah. So so it's poor spider, but it's kind of neat to see that it's not just a human physiological thing. It's that you're affected by gravity.
We posted that video on Universe Today, and then we tweeted out the description of the title, and I loved the responses we got back from people because it was very much like, let's send them all to space. Like, posted like, spiders have trouble adapting to low gravity, and someone just wrote back and said, good.
All right, so we have arachnophobia going on.
We have a few arachnophobics, in our readers. What's this, David? What are you posting a picture?
That is a cell phone photo from earlier today that went around Twitter. I verified that it's from Tibet. It's from a Chinese Long March rocket launch. That is wreckage from the first stage, right there. I did a Google search to make sure that the image wasn't something that had been pilfered from anywhere else. The trajectory from the village looks right from the launch center that they gave me, so that probably is indeed real. And it's happened before that this kind of wreckage has turned up after a launch, because they said they go out of Inner Mongolia. They're right up over China, basically, in Tibet. So the satellite was successfully launched. That's not a failed launch, but that's just the first stage right there. So
that is something. Wow. It's just like a sort of a lack of respect for the population. Can you imagine if the Americans kind of launched rockets?
I've thought that before too. Yeah, all ours go out over the ocean. So.
Yeah, can you imagine if they launched them east out of, I don't know, Chicago? They just like landed randomly in, New York.
Well, people collect them up for scrap metal too. There's actually in Siberia and Eastern Russia, there's a cottage industry in collecting those up for precious metals and scrap metal too.
It's like Pacific Rim, where they're collecting up the kaiju. Cool. Okay, so I think we got one last story before we wrap up for the day, and we're going to talk about the ExoMars rover update. Elizabeth.
Really excited about this. So Europe has a rover that's going to be going to Mars very soon, in about 2018, I believe it is. But the thing is, they don't want to be just sending it up there and learning everything on the fly, because this is going to be their first rover. NASA's pretty experienced with their rovers up there, but Europe is still learning. So what they decided to do was to actually run a full test of a prototype in Chile in the desert, which is a pretty challenging environment, sort of similar to Mars, of course. And they were not only going to be testing the rover, but also testing how their mission control was going to work in a sense. And so they worked through, I think it was supposed to be the equivalent of 2 sols every Earth day, although in reality the sol on Mars, the Mars day is a bit longer than the Earth day. But anyway, they went through several sols, as they called it, of procedures on here. And it was a pretty cool test because they tried to make it as realistic as possible. For example, they had a high-altitude drone fly over, and take some pictures of the site, just like what would happen with a satellite. And then they looked at the satellite picture, so to speak, and they decided where they were going to deploy the rover. And so then they would put the rover out there, and they would try and run through a few commands to see how that would happen. And there was an added challenge too, because the desert is kind of a hostile environment, and they only have the one prototype, so they didn't want to be doing anything too hazardous with it. So at the end of every night, they would actually bring it back into shelter and then bring it out again in the morning. So just to make sure that there weren't any added clues for navigation, they actually would send out these guys and sweep the desert just to make sure there were no extra tracks that were showing it going to or from various areas. So that was pretty interesting. And there actually were quite a few hazards that they were facing while they were out there. I mean, not only is it desert and very dry, but there also is a risk of dust devils, and at one point they actually had to stop everything and flee and run for shelter because there was a dust devil that kicked up a bit of a storm in the area. Fortunately, nothing was seriously damaged, but it did disrupt things, and it does show just how unpredictable sometimes space exploration can be. So they're still waiting to see how successful the entire trial was. But they're saying so far it was doing some of the things it was supposed to be doing, taking pictures and probing underground. Sorry, they weren't actually probing underground with the rover, but they were doing a simulation of that. And they're saying that the work itself has been a fantastic learning experience. That's their words exactly. And they're hoping that they're going to be learning quite a bit for the actual mission.
How do you think this mission bodes for the future of perhaps a return sample mission? I know sort of that was after ExoMars, the next big thing was start to move towards a sample return mission. Where are we at on that front?
Well, we have to figure out how to drill down into the surface a little bit better, and I should mention that in this particular simulation they weren't doing that with the rover. What was happening was they would get to a site and they would say, okay, it looks like a good spot to drill, and then the prototype actually wasn't equipped with that drill, so they would have to stop things for a second and have a human run out there and drill, and then have the human leave and have the rover do the analysis just like they would do normally. What's with my English? Anyway, so what they have to do first of all is figure out how to get the drill into there, and then figure out how to get that safely ensconced into the capsule, and then get that out of the atmosphere. So it's a sequence of complex events, just like with the Hayabusa asteroid. It's sort of, you got to get this engineering problem fixed, and that engineering problem fixed, and that one, then that one. And it's dependent on time and funding and ingenuity. So probably I wouldn't say too soon, but this would be a good step towards that process for sure.
I wonder who the lucky astronaut is going to ride with the ExoMars to Mars and perform that drill switching task.
Well, that's exactly it. Who's going to be hiding inside of the spacecraft and then just jumping out at that perfect moment to get that done, and then doing it all secretly too. Some kind of a big conspiracy, I suppose.
It's the Simpsons episode where Homer builds a robot for his son. You seen this? No. And they fight robots. They fight. He joins a robot fighting league, and but he's just inside the robot suit, and he's getting chopped up by the robots that he's fighting.
See, there's a Simpsons episode for everything.
There is, absolutely. And my kids just watch them one after the other, and so now everything I see is just a Simpsons reference. All right. So let's wrap things up then. So we've had an hour. It's gone so fast. We had so many stories. This is great. I appreciate you guys keeping up at this breakneck pace. All right, so I'm going to say goodbye to people, and they can get some more information. Alan Boyle, where do we find out more?
Oh, cosmiclog.com. That's good. Takes you to the NBC site, or I'm on Twitter at B0YLE.
Anything super interesting that you're working on that you can't talk about?
Yeah.
Cool. Amy Shira Teitel. Where do you find out more?
More usually space history at amyshirateitel.com is where all of my stuff lives. My blog is now at Popular Science, Vintage Space. You can Google that and find me, and I'm other places, but my website will kind of post it all. Twitter, AST Vintage Space.
But Vintage Space is now officially over at Siam?
Yes, it is.
Nice.
No, PopSci.
PopSci,
Cool.
sorry,
Yes.
not Siam.
I do videos for them. It's all good.
Right, hardest working person in space journalism. Okay, David Dickinson, where do we find out more?
This week I was active, Canada.com, Universe Today, my own site, AstroGuys with the Z, and I will be doing a public free star party at Brooksville tomorrow night at the Chinsaga Nature Center starting at 7:30 p.m. So if you're in Florida, come on out. We're actually going to be under dark skies instead of doing the usual star party in a parking lot with overlit illumination where we can only see like Jupiter or Venus or something like that. It's rare we get to do a star party under actual dark skies for the public.
That sounds awesome. Elizabeth, where do we find out more?
Usually the best spot to find out everything that I'm doing is to head over to my social networks. And so Howell Space is my my Twitter handle, which I just belatedly put down here, the solar flare, so I wiped that out as well. And I also have my Google Plus account. And yeah, so basically I'm posting on Universe Today, Space.com, Space Exploration Network, and a few other places besides. So check it out. Hopefully I can connect with you there.
Fantastic. And Nancy Atkinson.
At Universe Today, and social media at Twitter, Nancy_AM on Google Plus, and Facebook sometimes.
Very cool. So the next thing that we'll be doing is we're going to be doing the virtual star party on Sunday night. So hopefully we're going to have nice clear skies and no moon, so it should be really good. All right, so thanks everyone for joining. Thanks to all the journalists for participating. Thanks for everyone for watching, and we will see you all next week.
Is that deliberate?
Big sigh.
All we get to hear
It's a
is
nice
big
entrance.
sigh. Not a ta-da. All right. Well, hi, everyone. Oh, I don't even have a... Who am I? Who is this guy? All right, there we go. Hi, everyone. My name is Fraser Cain. I'm the publisher of Universe Today, and this is your Weekly Space Hangout for October 25th, 2013. Today, we have stories about more information on the spacesuit leak, the asteroid panel that happened today. More information on other comets, not just ICID, but also ISIN. We've officially crossed the 1,000 exoplanets mark. Testing of the ExoMars rover, the furthest galaxy, Chinese scientists unbanned, cool activity on the sun, and hopefully we'll get to see a spider in low gravity. Joining me this week, an awesome panel of space journalists. First, we've got Alan Boyle.
Hi.
And we have no idea what Alan's going to talk about, so we'll find that out.
Neither do I.
No, you know what? You're going to talk about the asteroid panel because I know
Okay,
you were, you
that's
were
a
in
deal.
on that. Yeah. And then just like whatever, you just interrupt. At some point, interrupt whatever we're doing. Go, oh, I want to talk about this. And then
The usual in
yeah,
Thor.
go ahead. Standard Alan Boyle technique. Amy Shira Teitel. Hey, Amy.
Hello.
We got David Dickinson. Hey, David.
Yay, it's finally fall here.
Is it?
Yes, it finally feels like fall here.
Oh, okay. Elizabeth Howell. Hey, Elizabeth.
Hello.
Oh, you've got the Vulcan salute as well. All right.
Why not? Yeah, Alan had that last week, and I
Yes.
decided to use the same thing. So.
My brethren, or sistren.
And Nancy Atkinson. Hey, Nancy.
Hi, we reach.
Okay, so I think the big story then today was this asteroid panel that happened. So it was sort of a live broadcast on how to protect the world from asteroids, and a bunch of people here watched it. We broadcast it live on Universe Today. So Alan, can you give people an update on what this was? Let's take the arrival of Alan
Yay.
as a sign that we should get this party started. He's muted though, so we can't hear him. There we go.
Sure. Actually, for years, a group of astronauts and experts on asteroids have been trying to figure out a process for dealing with the asteroid threat. What do you do if you do find an asteroid that poses a significant threat to Earth, and how can you do more to find those things in the first place? And so the UN has been involved in this process for years. Just this week, a committee of the General Assembly of the UN considered this plan that a lot of folks have been working for years on. And so this was the news peg for today's panel by 5 astronauts from various countries, US, Japan, and Romania, and moderated by Neil deGrasse Tyson. And so they laid out their action plan for going forward, very much based on the UN plan, trying to set up networks so that various space agencies can keep each other posted on what's going on with asteroids. And they also called for a couple of new missions. One would be an infrared space telescope that would be dedicated to looking for near-Earth asteroids from a vantage point that would be really useful, kind of inside the Earth's orbit, looking for these space rocks that may come out of the blue, like the Chelyabinsk meteor that we saw in February. And so they would like to see that launched by 2020, and then have something in the 2022-2023 timeframe that would be a demonstration of how you could push an asteroid around to get it out of the way. So that's the top line, really a consciousness-raising exercise for the asteroid issue.
And I mean, was there any ideas, anything in there that you hadn't heard before?
I think it's been knocked around a little bit, but the idea of trying to get a time frame and trying to lay out a timeline for these missions and to have an action plan, I think even though they've been talking about this for years, putting it all in order and trying to present it to the public, that's a really useful thing. I think, as Rusty Schweickart said, Apollo 9 astronaut who is part of this group, now we have the skeleton, and it's up to us to put the flesh and the muscle and the brains onto this skeleton.
That's a Sentinel. That's a Sentinel mission you're talking about, right, Alan?
Actually, that's something that came up, is that the Sentinel mission, which B612 Foundation has been working on, is one possibility for this. But there's another possibility called NeoCam that NASA has been working on, and so you've got these two missions. They're actually kind of complementary. NeoCam can do some more of the scientific work in addition to cataloging these asteroids. Sentinel is very much dedicated to finding and tracking these asteroids, and so I think when both these missions came up, Phil Plait said last year that we should do them both. But
interesting. I didn't know there was another one.
Yeah,
but it's
coming
great.
Up 2016.
The B612 Foundation has really been tirelessly working in getting the word out, raising awareness, and staying on top of this even before the Chelyabinsk meteor and after. They've been doing a really good job. And I know Rusty Schweikert is part of that, and Ed Liu, and hopefully they're just going to keep grinding. And so if nothing from NASA or the international community ever happens, they're still pushing this agenda forward.
Yeah, that's why they're doing this, because they've been frustrated with how slowly things have been moving, and how difficult it is to get NASA really on board as much as they think NASA should be. And so they've been working to raise money. I don't know if there's an updated report. The last I heard was that they had $2 million or perhaps several $1 million toward what's expected to be something like a $450 million mission. So really all they need is one